Okay, so rounding to decimal places and significant figures, and this also impacts estimating answers. So if we look at rounding to decimal places, so for example, if we have 0.7624, okay, you've done some sort of calculation and that's the answer that you've got, and they say round to 2 decimal places, or DP. Well, there's your decimal point. So there's your decimal places. They're your first 2. Now whenever you're doing rounding, it's always the next number. Okay, so there's my 2 decimal places, 0.76. So the next number is a 2. So it's just a question of, do I round up or do I round down? Okay, so I'm sure that you all know that with 2 we would round down. So anything after this we have no interest in. So that number would be 0.76 to 2 decimal places. Okay, so if we have the numbers 0, 1, 2, 3 and 4, then we always round down. Okay, if the next number is a 0, a 1, a 2, a 3 or a 4, we round down. If it's a 5, 6, 7, 8 or 9, then we round up. Okay, so just to give you an example, so if we've got 0.1362 and they say to 2 decimal places, well, they're my 2 decimal places after the decimal point. The next number is a 6, so I round up. So this number, the number next to it, is rounded up, so the 3 becomes a 4, so we get 0.14. Okay, so for example, again, if let's say we've got 0.06123 and they say to 2 decimal places. Okay, 1, 2. Don't be afraid to underline things and write on it. It's totally okay. The next number is a 1. A 1 rounds down, so the 6 stays as it is. So we get 0.06. Okay, we have no interest in this because these numbers are getting so tiny that they are insignificant. Okay, and it really is that simple. Don't try to overcomplicate something that is simple. Now let's say again, let's take those same numbers, 0.06123, and they said to 1 decimal place. Well, there's my 1 decimal place, 0. But remember, we go to the next number, which is a 6. So we round up. So this 0 now becomes 1. So we get 0.1. Okay. So this is, it really is that simple. Is always look to the next number, and that will tell you whether this number is going to be going up or going down. Okay, so rounding to decimal places you're probably familiar with, you're probably okay with, but it doesn't hurt to go back over it. Okay, now significant figures is probably new to you, so let's see if we can put this into something you may understand as real. So let's say you've won the lottery, so you've won £3,847,951. Okay, so sure as shoot you're not going to be doing this course, and if I won it I will be teaching it, but this is real life. So you've won 3,847,951. Our most significant figure, the most important figure, is this one, the 3 million. Because if you were to lose £1, you wouldn't be too concerned. If you lost £50, you wouldn't give a toss. If you lost £900, you wouldn't worry. Okay, because you got 3 million. If you lost 3 million and only had the 847,000, you'd be a bit miffed. So this is your first significant figure. Okay, and we tend to write sig fig for significant figures. Okay, so the first number is your first significant figure. Okay, so if somebody said to one significant figure, what is 3,847,951? Well, this we now know is your first significant figure. Now, exactly the same as decimal places and the next number. So we look to the next number, okay, which is an 8. Now, because it's 8, we would round up. So the 3 would become a 4. And all of these other numbers all become zeros. Okay, so 3,847,951 to one significant figure is 4 million. Okay, so we find our significant figure. You can have 2 significant figures, 3 significant figures, 4 significant figures, but we always go to the next number to decide if we're going up or down. But this number, the 3, becomes a 4, but it must maintain its value, so it can't just be 4, it has to be 4 million. Okay, so let's do it with smaller numbers. So let's say we've got 587. Okay, and they say, what's that to one significant figure? Okay, so there's our one significant figure, the very first number. So we look at the next number and we decide if we're going to go up or down. Now, because it's 8, we round up, so the 5 becomes a 6, but it isn't just 6, okay? It was 500, so it now becomes 600, okay? Because these numbers now turn to 0, okay? So if I've got 8,299, and again to one significant figure, there's my one significant figure. I look at the next number, which is a 2, so that rounds down, so the 8 isn't affected. And these now all turn to 0, okay, because the 8 must still become 8,000. Okay, so let's say we've got 57,863, and they say to 2 significant figures. So I go 1, 2, because they're significant. Then my first 2 numbers. So I then look at the next number, okay? The 8 means we round up. So the 7 becomes an 8, so we get 5, 8, and everything else turns to 0. Okay, so we get 58,000. So when we've got significant figures, if we've got one significant figure, we will only have one number that is not a 0. If we have 2 significant figures, we will have 2 numbers that are not zeros, the rest are zeros. Now the thing about significant figures is it doesn't care about the decimal place. So if we have 0.007621 to one significant figure. Okay, so this is significant figures, not decimal places. So these zeros are not significant. Okay, 0 before numbers are not significant because they have no value. So it's not until we hit the 7 that we get a number that has a value. So that is our first significant figure. So we look at the next number as normal, and we have 6. Now we know that's going to round up, so the 7 is going to become an 8, so we'll get 0.008. Now because in theory these all turn to 0, okay, so we will get 0.008,000. We have a saying in maths, trailing zeros have no value. Okay, if I write 2.5, you know what 2.5 is, and it's 2.5. If I write 2.500000, these zeros don't make a scrap of difference to this number. It's still 2.5. So these zeros are not written in. So exactly the same, we don't write these zeros in because they have no value. So 0.007621 to one significant figure would be 0.008. Okay, so if we have 0.067214, okay, that looks fairly horrific. And we have two significant figures. Well, we come along until we get a significant figure, which is 6, and we want two of them, so we go 1, 2. We look at the next number, which is a 2. So that means that it rounds down, so it doesn't affect the 7 at all. So all of these are irrelevant. So our answer is 0.067. Okay, and that's the two significant figures. Okay, so you'll be able to see, hopefully, that this is, you've got a 3 decimal place number, but it's two significant figures. So significant figures and decimal places are different. Okay, just to show you that, if we've got 14.87216 and they said to 3 significant figures, well, 1, 2, 3. They're my 3 significant figures. They're my first 3 numbers. I look at the next number is a 7. So we round up. So this 8 becomes a 9. So we get 14.9. Okay, because all of this has no value anymore, because we've now rounded that to 8 to a 9. So this number to 3 significant figures is 14.9, but that's what it is to 1 decimal place. So the two things are separate. Okay, so very rarely in an exam will they give you something like this and say, what is this to so many significant figures or so many decimal places. They will get you to do a question and then say, give your answer to 2 significant figures, or 3 significant figures, or 4 decimal places, or 1 decimal place. So it will vary. Okay, it's usually tagged on at the end of a question. So always remember, and the next number. Okay, you're always looking at the next number to see whether to round up or round down. And that significant figures, taking this number here, zeros are not significant until we hit a number. Okay, this is after decimal point, so until we hit a number, zeros are not significant. They are if they're in the middle of a number, for example, or if we've got a big number like 85,000, they are significant. But in decimals, zeros are not significant. Okay, so I hope that helps. If not, you know where I am and I'll go through this with you. But hopefully you'll see that it really is simple, and because it's simple, don't try and overcomplicate it. Okay.